So let's start. And I'm very happy to have with me now Frank Mu from BayWa r.e, who will give the opening speech. Frank, the floor is yours.
Thank you very much, Michael. Am I able to share? You just stopped sharing. Okay, 1 second. So please let me know if you can see my screen. Can you see it, Michael?
Oh, good. Perfect.
Okay, then thanks, Michael, for the nice introduction once again. And yeah, hi, everyone. My name is Frank Mu. I'm from the procurement team from BayWa r.e solar projects in Germany. And I'm personally located at our Freiburg office. And yeah, my background is in mechanical engineering and as well as a master in sustainable systems engineering, which is actually what took me here to Freiburg about 7 years ago now. And yeah, I've been in the BayWa team for the last 5 years, and my team is now responsible for the purchasing of PV modules, which I originally started with, and now also inverters and battery energy storage systems, or BESS. So earlier this month, I had the pleasure of finally meeting Mr. TaiyangNews, Michael Schmeller. And yeah, here I am today, 2 weeks later, with the pleasure to speak to you all. When it comes to the components themselves, I cannot say I'm an expert like the other speakers in this event, but I will try to give you my best view of what is important when it comes to the purchasing of PV inverters and BESS. And my apologies in advance for my hastily put together PowerPoint presentation. So firstly, BayWa r.e is part of the BayWa group, which some of you may know has existed for over 100 years now. And we historically was operating in the agriculture industry, such as with grain trading in Germany. And later, particularly in the last decade, we expanded a lot into the renewable energies industry. And this included mostly utility wind and solar projects. BayWa r.e also has a solar trade business, which is one of the largest in Europe. And lastly, in the last few years, BayWa has also joined the now booming industry of utility storage projects. So BayWa is globally divided into 3 regions. And when it comes to the purchasing of European projects, it's done through our central team based in Germany, led by our global head of purchasing, Timo Galizia. And so, hello to my team, whoever is listening. Unlike procurement, though, other project operations, such as project development, management, engineering, are all managed mostly through the local countries. But for procurement, a central team has advantages when it comes to the relationship management and purchasing power, so we choose to keep procurement central. So quality and reliability is BayWa's core value, and to do it efficiently, we prioritize standardization as much as possible, and to minimize variation and reduce special design changes between each project. So as you all know, special changes can lead to unexpected problems and delays. And for solar projects, we have 3 types of projects, namely fixed tilt, tracker, and floating, which all have standard design blocks with matching standard inverter types. We also provide a performance guarantee for our projects, which means that we are not just responsible for the construction and handing over of a project, but also bear the consequence of underperformance. So purchasing experience and know-how is of the utmost importance for me. And the key has always been to understand the product and the market. Inverters make up, in the end, only a small part of the total cost of the PV plant. And one might think that inverters simply convert DC to AC, but actually it is much more than that. So while PV modules affect the performance greatly, but without inverters, actually no energy can be produced. The inverters are probably the smartest part of the plant, or like the brains of the system. Not only do inverters keep the PV modules operating at its maximum power point, and ensure that the AC output is sinusoidal, inverters must also be resilient to grid-side fluctuations, which is exactly what Michael talked about at the start, having the importance of having a resilient grid. Inverters must also offer many safety features, communicate with other inverters in the plant, respond really fast to changes, and also comply with all grid codes while operating in all sorts of extreme conditions. things like the number of number of MPPTs and other MPPT parameters are also crucial to the planning of future projects. So for the same size inverter, we know that they are different products with different numbers of MPPTs, which for us can impact the design and performance of the plant greatly. So for PV modules, the market, as you all know, is very saturated with many different suppliers, but in the end, the product itself is not so different. And this makes it, in many cases, very easy to compare performances of different products. I mentioned this because when it comes to inverters, performance comparisons are not always as easy. So manufacturers offer a huge range of features, but it is known in the industry that not all suppliers' products can perform just as well as they claim. And don't get me wrong, the differences between different products could be a percent or even a fraction of a percent. But when it comes to a utility project, this difference in a few percent in the end can make a huge difference. And not only that, inverters are also more difficult to test in the lab and therefore simulate all the real-life conditions. Many problems later only arise in the field because the causes were simply unknown. And therefore, it is almost certain that there will be unexpected problems, and it becomes extremely important to have a trustworthy supplier to investigate and solve those problems quickly. So at BayWa r.e, we stick to a relatively small number of suppliers for inverters and prioritize building deep partnerships, first of all, with our suppliers. And it is important to keep digging deeper into the product and always keep asking questions. The number on the data sheet is not always the reality. And the procurement team needs to establish these connections with industry experts, which can be the suppliers, but also third-party institutes, and really understand the risk of the product. An effective partnership here means consistent transparency of communication throughout the whole product lifecycle, which, from clear communication of product roadmaps to preparing for our future projects, as well as continuously improving the product together and developing new future products. Unfortunately, the price of PV inverters has been relatively stable with a small downward trend as inverters increase in size and power and some decrease in the number of MPPTs. Inverters are only a small part of the total cost. However, choosing the wrong inverter or supplier, whether it's product defects or lack of supplier support, one can easily cause losses in electricity generation, which negates the benefit of any cost savings to start with. Now, moving on to battery energy storage systems. For us, for me, and for BayWa r.e, storage is a relatively new field, and I believe for many of you here today. The market is exploding with new suppliers, and battery cells prices has reduced significantly due to the overcapacity in the supply chain. And when I was first involved in BESS, the first thing that was made clear to me was that we in the PV industry are used to having components purchased and delivered to sites where we integrate everything together into the final PV plant. So the first thing to know about BESS is that it is not just an additional component of a PV plant. Although it can be installed alongside a PV plant, a BESS project has its own business case, its own system of different components, and therefore very unique challenges of its own. So unlike PV, which generates electricity to be sold, battery systems need to be charged and discharged to generate revenue. And for procurement, understanding the revenue streams and how the project can be profitable can help define purchasing strategies. So why is it worth spending millions of euros to install a big battery? And what does it offer to the grid? Or what does it offer to the investor? A competent procurement team for BESS should start with a good understanding of the business case as well. So what is the so-called revenue stacking and what is the target IRR? Now, without understanding the project and the market situations, it is difficult to master the commercial and technical needs of the project. How the BESS functions technically and how components integrate together must also be understood. Parameters such as state of charge estimation, balancing, round-trip efficiency, C rates, and many, many more. Here, we work with external and internal experts like suppliers and third parties to understand different perspectives and getting involved to optimize requirements and testing procedures to make sure what we buy is really what we need. So purchasing of the BESS can be roughly split into the DC and AC blocks, where DC is a battery container and AC being the inverter, PCS, and transformers can be categorized into 3 different types at BayWa r.e. We call it the full system integration, semi-self-integration, and the full self-integration. So for the full system integration, this is where we buy a full system completely designed or procured by a single supplier, like Fluence, Tesla, or Sungrow. These suppliers can often also offer turnkey EPC services as well as long-term O&M services. And system integrators have also been successful in the market because developers are all relatively new to the market, and therefore we could rely on the expertise of the integrators. As developers gain more experience, semi-self-integration is very similar to full system integration. This is where we are still working with one supplier, but they allow us to define some of the DC and AC blocks. And these suppliers can sometimes be also the cell suppliers themselves, who have less project execution experience. This allows us to avoid having to contract different component suppliers directly, but still freedom to choose the components which we want to use. But it can lead to additional risks as well. Then comes the full self-integration method, where we are contracting the DC and AC parts of the system separately and carrying out all the technical integration and design, where we are free to decide everything. It has theoretically the lowest capex, but also the most demanding in terms of experience and know-how. So with each step towards self-integration, risks can arise, such as uncertainty for warranty obligations, technical integration expertise, timing risks, system compatibility risks, and it all becomes more resource intensive and requires more experience and know-how. In the future, BayWa r.e. one day wants to be able to do self-integration and use system integrators for emerging markets. Product-wise, we have to talk about the cell technologies out there. NMC or LFP in terms of lithium-ion batteries, even though mostly are now LFP batteries, it is still important to understand the pros and cons of each. Other technologies like sodium-ion batteries or even zinc or magnesium or maybe solid state are alternatives as well, and also very different technologies like redox flow should also be understood and monitored. And by doing this, we can also have a different view of where the strengths and weaknesses of our existing solutions are and where we might have a business case in the future. Apart from the cell technology, it is also much more important to evaluate the supplier in general, such as aspects to do with servicing, where their servicing team is located, which kind of scope they can fulfill, as well as other topics like supply chain and ESG. Now, the price has been a key factor in the last years, as rapidly dropping prices in the battery cells have caused BESS to become a popular investment. In this case, it is also important not only to have a price adjustment scheme in the contract, such as against lithium carbonate, but also the timely execution of the project to ensure the project case survives. Now imagine having purchased a 3 million euro BESS system only to have the market price of the system drop to 1 million, for example. And by the time the project has finished, the business case has changed a lot. The choice of the purchasing strategy as well as the supplier is extremely important to avoid potential delays. Although it may seem like getting the cheapest option is more important than ever, it needs to be stressed that all the savings can go down the drain if the integration and execution, as well as service and operations, are not done well. So like a PV system, there are many risks associated with each decision and performance of each component or supplier. And this must be understood thoroughly to make a decision. Things like fire suppression standards, capacity degradation, supplier service, warranty terms, even regulatory requirements. As we see more and more products on the market and ever increasing capacities packed into a 20-foot container. One must also think about topics related to noise, logistics, reliability, serviceability. The procurement team must therefore be in frequent exchange with our engineering and R&D teams to keep each other updated on the market requirements. With increasing competition, it is also becoming more important to understand the true performance of a product and not blindly believe what the supplier promises on their data sheet and warranties. At today's stage, as we are relatively less experienced, we choose to focus on suppliers who have the experience in Europe and also local service teams in our key markets. BayWa has recently completed 2 hybrid BESS PV projects in Germany, which use components from a large European BESS integrator. And these 2 projects also highlighted the need to have consistent communication and clear split of scope and responsibilities for both parties, as many unexpected problems can occur during construction and commissioning process. In both cases, we agreed on a mixed scope of work, which was also a good learning opportunity. Both projects are expected to be commercially operational, operated by the BayWa r.e IPP within the next month, where one is already in operation. And from all the lessons learned after these projects, it is important to also take a step back and think about which homework needs to be done. But when it comes to the purchasing of BESS and inverters, there's one clear trend which also applies for PV modules, and that is the manufacturing of components is heavily concentrated in China. And as a result, the EU, as well as many other states around the world, in order to protect their local manufacturing, are implementing protective measures in various forms, such as the Net Zero Industry Act, or NZIA in Europe. And this topic is already quite a hot topic for PV modules. Therefore, the procurement team is also monitoring the market and the manufacturing sector within Europe, including building these relationships with local manufacturers, even though they might not be viable right now. At the end of the day, the market can change quickly, and we at BayWa r.e are learning about new opportunities, and we do not stop growing and learning that there's always new challenges to overcome. And just when you think the inverter is already big enough, there's a bigger one around the corner. And just when you think the BESS container is getting too heavy, you bet there's a heavier, more energy dense container coming out soon. And the key thing is understand why and how these things can affect your business and adjust your strategy accordingly. Thank you very much for listening.
Thanks, Frank, for sharing your procurement insights with us. Here, maybe one question for me, and then, if there's anything else in the chat, you might want to take it from there. So you mentioned actually that in these days where costs are decreasing quickly, but prices have been decreasing even quicker, it's difficult to make the decision when and what to buy exactly. So how do, and at the same time, of course, so much is happening also when you look at standardization, because the field is pretty new, especially this hybrid field, and a lot is happening there. So how does this development of new inverter products and other products in the market affect BayWa r.e.'s plant designs and standardization?
Yeah, I mentioned standardization in terms of PV inverters because we typically want to design our projects using almost copy-paste blocks. So we define blocks first, our engineering does this, and they try to minimize any differences between each project. They just copy-paste. And this also means we have to find the best fitting solution in terms of string length, how long the tables are, how long each string is, and ensuring that in PPTs, so maximum power point trackers, are limited only to small areas. So if you have such a long table with one MPPT, then different conditions can occur in different locations, different parts of the table, which can reduce plant yield in the end. And yeah, as I mentioned, the cost of the inverter is relatively small. So even if we choose the cheapest or the most expensive inverter, it might be just a tiny percent or 0.5%. And in the end, if we cannot get the optimal block design that this 0.5% of savings can easily, go down the drain, and the losses in the whole lifetime of the project can go much higher than that. So therefore, we choose to actually stick with slightly smaller inverters, 200 to 250 range, because we find this is much more flexible when it comes to our design philosophy.
So even for the bigger plants, for the real big plant?
Well, it depends, of course, also if the plant is very flat, then maybe MPPTs are not such a big deal, and we can have then also the bigger inverters where there is a case for it.
Okay, cool. Thanks so much. I see there is already one question asking for your contact details. There might be more in the chat, Frank. So it would be nice if you could stay online and answer questions if there are any. Okay, thanks a lot.
Thank you very much.